Now for this worksheet, in the instructions, they said give answers only, but keep the reasons in mind as you make conclusions. In case for exams, that won't be the case. We will always want you to write down the reasons. But I just said to yesterday's group, let's just practice using the theorems, and then when we do questions where they all mix together, then we'll focus on writing the correct reasons. I did also post a document that says acceptable reasons. All the circle reasons are there, and those are the ones that you need to use. Okay, so worksheet 3, I do have the answers here, but I think it would be good if we just fold them all in together so that we can go through how to actually find them. So for this exercise, if you spent a lot of time writing down reasons, sorry, okay, it would have taken long, but it was the same reason in most of these cases. Okay, so in the diagrams below, O is the center of each circle here. Determine your answers in alphabetical order, give answers only, but keep the reasons in mind. So we are going to talk about the reasons, but we're not going to write them down. So guys, if we're looking at this 80-degree angle, do we notice that it is an angle that is subtended, that's formed at the center, right? So 80 degrees is the angle that we have at the center. And this 80-degree angle is subtended by this arc. Now, I did explain it in yesterday's lesson, but subtended by an arc or a chord, because we could actually have just done this, right? I can just take a ruler and I can just connect those 2 points like that. And now all of a sudden, this angle is subtended by the chord, all right? It doesn't change the angle. So an angle can be subtended by an arc, which is a section of the circumference, or a chord, which is a line that goes from one point on the circumference to another point on the circumference. All right, now subtended means that if you take a line from the end point of the arc or the chord, one of those two endpoints, and from the other endpoint, right? So we have lines going from each endpoint, and they go and they meet somewhere. There where they meet, an angle is formed. And we say that that angle is subtended by this arc or this chord. All right. So this arc in this case, or this chord, actually subtends two angles. It subtends the angle at the center, and then it subtends the angle at the circumference. Now the theorem that we went over yesterday, which is on that first page that I gave you. Is it the first page? Oh, sorry. On the second page, actually, on the back of the first page. All right, it's this one here. The angle subtended by an arc or a chord at the center of a circle is 2 times an angle subtended by the same arc or chord at the circumference. So here we can see if that angle is A, that angle has to be double A, 2A. All right, but now they've given us the one at the center. They've given us the 2A. So if this one is 80, what must A then be? 40, half of that one. All right. So for this one, angle A is 40 degrees. If you had to write the reason, it would be angle at center equals 2 times angle at circumference. Unfortunately, you have to write that whole thing down. Okay, bit of a loss. Next one, B, now they're asking for, which is the angle at the center. They gave us the angle at the circumference. The one at the center is always double the one at the circumference. So what is double 48? 2 times 48 is 96. Your reason would be the same. Angle at center equals 2 times angle at circumference. Now this one, number 3, this one is a bit more difficult to see, all right, because it doesn't look like this where the one angle is kind of above the other one. But do we agree that the angle at the circumference here, 34, is subtended by that arc? Because we have lines going from the 2 endpoints, and where they meet, we have a 34-degree angle at the circumference. Then angle C is subtended by that same arc, because again, if we take a line from the endpoints of the arc, those 2 lines meet at the center and they subtend angle C. All right, so this one is at the circumference, that one is at the center. This one is supposed to be double that one. What's 2 times 34? 68 degrees. All right, now number 4 is a bit more difficult. People usually struggle with this one. Because in this case, the 123-degree angle that we have there is subtended by this major arc over here. So now I wonder if people said that D is going to be half of that one, right? You might remember this from last year. Again, on this page that I handed out, on the second page, the one that is half a page, there they have variations of the diagrams, all right? So here we have this kind of shape. Do we see that it looks like number 4? Just move it down. There, it's almost like we have a quadrilateral like inside that circle, but it's going from the center, right? Same thing there. So that is the angle at the circumference. The outer one is then the angle at the center. All right, the angle at the center and the angle on the circumference or at the circumference, they have to be almost like on the same side, right? So it can't be that this one is at the center and that one is at the circumference. They both have to be like below the shape, if that makes sense. All right, so here for this one, in order to find D, you actually first had to find this one. This one is the angle at center that is subtended by the major arc. So this one, we call it reflex O, if we had to write it down. This outer one would be double 123, which is 246. Right, so that one is the one at the center, when that angle at the top is at the circumference. This one is angle at center. And now if I have 246, how can I find D using that information? Yes. Yes, good. Revolution or angles around a point. These two angles must be equal to 360. So we're going to say D is 360 minus 246, which is 114 degrees. All right, we'll do other exercises later on where we'll write everything out properly. For now, we're just practicing to actually see these things. All right, next one, E, angle at the center. 50 is the one at the circumference. What is E supposed to be? 100, good. Now we must find F. Now guys, this kind of scenario happens all the time, all right? It happened in so many of these questions, where this triangle here is actually an isosceles triangle. Because what is this line? A radius. And this line is also a radius. So these two lines, those two sides of the triangle are actually equal. The same thing happens in number 6. Here we also have an isosceles triangle because our two radii will be equal. The same thing in number 7. I'm just putting them in so long. And again in number 8, we also have an isosceles triangle there. And that's something that comes up very often, guys. We need to use that to actually get the size of F. Because if this angle is F, isn't this angle also going to be F? Right? If we have an isosceles triangle, we know if these two sides are equal, then those two angles will be equal. What is the reason for that? Can you remember? Angles opposite equal sides. You had the words, but they weren't in the right order. Angles opposite equal sides, all right? Because that is how it actually works. We see that this angle is opposite that side. This angle is opposite that side. So it's the angles that are opposite the equal sides that will be equal. All right, so that's the reason. And what do I know about these two angles together? If that angle is 100 degrees, what must these two angles together be equal to if we have 3 angles in a triangle? 80 degrees, hey, because all 3 must add up to 180. I have 100 degrees already, so these two together must be 80. And if they're equal, then they're both going to be 40. All right, so that is what you had to do for that one. Now, when you write that down, you're actually going to have 3 reasons in the brackets. You might remember it from last year. You definitely would have done it. The first reason is going to be angle, sum, and triangle, because that is how we know that the 3 angles must be equal to 180. Then you're going to say angles opposite equal sides. All right, that is saying that it's an isosceles triangle. But how do you know that these sides are equal? Radii. All right, so that would be your 3rd reason. Again, we'll write them all down later on. Okay, any questions on this one, guys, on number 5? Okay, number 6. Now they've given us this angle here. Like I said already, it is an isosceles triangle. So what is G going to be? 35. The reason for that would be angles opposite equal sides, but also radii. Okay, because that's how we know that those sides are actually equal, because they're radii. Then H, 35 plus 35 is 70. right? So what must h then be to make 180 if we have 70 already? 110. So now that is the angle at the center, is 110. The angle at the circumference has to be half of that. What's half of 110? 55. Okay, number 7. We have the angle at the circumference. So what is the angle at the center going to be? If that one is 60, this one is 120. Good, double 60. Now we have to do the same thing that we did in number 5, right? Because now we're finding this angle, but we know that these two angles will be equal. If that one angle is 120, these two angles together must be equal to 60, all right? Because 120 plus 60 will give you 180. And since they're both equal, they're going to have to be 30 degrees each. Okay, so that is going to be 30. Again, you would say angle, sum, and triangle, angles opposite equal sides, radii. Okay, number 8, we have 48 degrees. Do we agree that that angle will also be 48 then? So now they're not actually telling us that we need to find that angle. There isn't a letter there, but we do have to find it actually in order to find the other angles. Okay, because now if we have 48 and 48, that together is 96. We need all three angles together to equal 180. What's 180 minus 96? Is it 84? 84. All right, so that one is 84. So to get to this 48, you would say angles opposite equal sides, radii. And then for that one, you would say angle, sum, and triangle. Now that one is the angle at the center. That one is at the circumference. So if this one is 84, this one has to be 42, hey? Half of 84. Remember, the one at the center is always double the one at the circumference. So that one has to be 42 degrees. All right, for the next one, they did say that we had to find these in alphabetical order, but you actually, oh, you could, sorry, wow. All right, so N we need to find first. We have the angle at the center is 96. The angle at the circumference must then be half, which is 48, right? We've worked with that one a couple of times now. 48. And now we need to find P. Now, guys, later on, the first new thing in grade 11 is working with cyclic quads, which is a quad where all the points are just on the circumference of a circle. So like this, it's like the quad is just like perfectly inside the circle. And the first new theorem that we're going to learn is that opposite angles of a cyclic quad always add up to 180. All right. So if you knew that already, then you could have said that P is going to be 180 minus 48, which would give you 132. But we don't know that yet. All right. So what you would have done at home was you probably would have used angles around a point to get this reflex angle over here, right? So that whole angle there is going to be 360 minus 96, which is 264. And now we can use angle at center to get P. All right, so now 264 is the angle at the center, and P is then going to be half of that. So 132. Okay, but once we know the cyclic quad thing, the opposite angles of cyclic quad, we could do that in one step. Okay, but that's only coming up next. Let's check how we're doing for time, 10 minutes. Okay, number 10. Same thing here. Do we see that again? We have our isosceles triangle because of the radii. So we have 108, and then these two angles will be equal. What's 180 minus 108? 72, hey, isn't it? 72. And what's 72 divided by 2? 36. There we go. All right. So these angles must each be equal to 36 degrees, so that when you add them all together, you get 180. Oh, sorry, we were actually supposed to get Q first. My bad. Q is the angle at the circumference, 108 is at the center, and they are subtended by the same chord, hey? Right? They're formed by lines coming from the same chord. So if that is 108, then Q has to be half of 108, which is 54. Okay. Next up, again, we have an isosceles triangle there. That is 36 at the circumference. Then S is going to be double 36 at the center. So S is going to be 72. And now we must again do that thing. If this angle is 72, then the other two angles must add up to 108, right? 108. So that these three angles will add up to 180. And what's 108 divided by 2? 54, hey? Now 12 was slightly different, all right? We had to find U, which is this angle over here. Now guys, are the 40-degree angle and angle U subtended by the same arc or by the same chord? Where is this 40-degree angle coming from? It's coming from this arc at the bottom, right? Now, is this U angle coming from the same arc? It's actually coming from a point there and from the center, all right? So completely different. So we can't say now that they're both subtended by the same thing, so they're going to be equal. What we do see, though, is that this angle over here is subtended by the same arc as the angle at the center, right? So if the angle at the center is 40 degrees, this one at the circumference is going to be 20. And for that, your reason would be angle at center equals 2 times angle at circumference. And now do we notice that we have parallel lines? All right, so now we can use alternate angles because those lines are parallel to actually say that U is going to be equal to 20. Okay. But if you just said U equals 20, angle at center equals 2 times angle at circumference, you wouldn't get any marks. Okay, because then it would look like you think that U and the 40-degree angle are subtended by the same arc or the same chord. Right, you would have to show that in between step. Okay. Yes.
You say that angle over the one that is
not angles in the same segment. Angles in the same segment is when this happens. So it's similar, but it's not exactly the same. It's when so angles in the same segment are always on the same side. So it's never like this. See, that's what we have there. Okay, so in that case, it would just be alternate angles, but angles in the same segment are always on the same side of the circle. Okay, now guys, I'm not going to go through the other stuff now. I want you to do the rest of worksheet 3, which you might have already done. Here we're just working with in terms of X, so your answers are going to have X's in them. And then you are going to do worksheet 4. Now, worksheet 4 is using, if I can just help you with the first one, do we notice that they didn't even tell us where the center of the circle is? Right, so we can't possibly use angle at center if we don't even know where the center is. What we do have is that angle A is subtended by this arc, and the 38-degree angle is subtended by the same arc. Just hold on. So these two are going to be equal to each other. If they're both at the circumference, they're both equal. If the one is at the center and the one is at the circumference, the one at the center is double the one at the circumference. All right, so for this one, A is going to be 38 degrees. This is this one. If you look on this summary page from last year, it's that one over there. Angles in same segment. There is a the there. I normally don't write the. I normally just say angles in same segment. Okay, so guys, you're going to have to look out for these ones now, all right? Angles in a semicircle, a diameter always subtends a 90-degree angle at the circumference, angles in same segment, and then equal chords, equal angles. If you have two separate chords that are subtending separate angles at the circumference, if those chords are actually equal, so if they're telling you that the one length is equal to the other length, they're going to subtend the same angles. All right, and the correct reasons are also listed there. Jasper, yes?
I was going to ask, what is the theorem that if all points are touching the circumference, then the angle is
So it is kind of this one, yeah. But it's actually saying that they have to be subtended by the same arc or chord. But in order for that to happen, all the points will be on the circle. Yeah. Okay, guys, so you need to do the rest of this one. Tomorrow we're going to practice a few riders, which is where we put all of them together, and then I'm actually going to write them out fully with the correct reasons. Again, I'm going to record that lesson, so you're going to have to watch it at home, please. And in there, we might even go on to cyclic quads towards the end of that lesson. All right. So guys, unfortunately, the syllabus is so full that we can't manage just teaching you on the day that you're here. So you do have to do some work at home. All right. But I do try to post it like literally as the lesson ends. Okay. So after I have you guys tomorrow, 11s, I have my 8s, but I'll try to either post it straight after the grade 11 lesson or at second break. Okay. But it should be up at some point. All right, let's see. 3 minutes left. You can pack up, guys.